Great. So we have these concepts in both the senior high school mathematics and additional mathematics. Okay. So that is the relations, mapping, and functions. These three concepts are related, but we shall take them one after the other. Now let's look at what a relation is. But before that, let's send our minds back to our daily lives. Let's think about our real life situations. So, in our various homes, families, our churches, in our communities, let's look at how we can get a relation there. So someone can ask you, how do you relate with people, or how do you relate to people around you? When we go to our various homes, we have our parents, we have our siblings, brothers and sisters, we have family members. How do we relate to one another? Good. Now, if I ask you to tell me, how do you relate to your father? The only answer you give me is you relate to your father by blood. The same applies to your mother. All right? Good. So it means that there is a certain connection between you. Okay. Now, when you go to our various churches, we have so many people that we meet anytime we attend church. Why do we meet those people? What do we do there? How do we relate to those people? All right. We relate to them because we have what? Common faith. All right. When we go to the classroom, we sit with our classmates, we sit with our friends, our colleagues, teachers. How do we relate to those people? We relate to our friends, our colleagues, because they are our classmates. We also relate to what? Our teachers, because they teach us. All right. So all these relations are connections. Okay. These are certain connections that exist among us. All right. Good. So that is relation. Now let's bring it back to the mathematics perspective. So now when we say relation in mathematics, we are saying that a relation is a rule or mathematical statement which assigns elements of one set called domain to elements of another set called codomain. Yes, a rule or mathematical statement which assigns elements of one set called domain to elements of another set called codomain. All right, great. Now I'm going to draw some diagrams. Let's use this diagram to explain what a relation is. All right, okay. Now let's look at the following diagram. So this is what we call arrow diagram. Okay, good. The first one, we have x, which is here, and the y. So the x and the y, they represent the two sets. Okay, all right, good. So you can see that we have Volta, Eastern, Ashanti, Greater Accra. So when you hear this, you know what we are talking about. We are talking about what? Regions in Ghana. Okay, now let's look at set y. What do you see? You will see that there's an arrow from element in x to what? Element in y. Each of them has their own what? Corresponding element. Good. So what can you say about this? All right, you have Volta marching to what? Ho. Eastern marching to Koforidua, Ashanti region marching to what? Kumasi, and then we have Greater Accra marching to what? Accra. So what comes in mind when you see that? What are we talking about? You realize that all the elements you see in Y are what? They are the regional capitals. Okay, they are the regional capitals. So in this case, we can say that the rule or the relation the relation among these, or the relation between the two sets, that is set X and set Y, is what? A capital of what? So Y is what? The capital what? Town, or the capital cities of the regions. All right. So the rule here now is what? The capital of. Have you gotten that? Now let's look at example 2. Example 2, as we have what? Set X and what? Set Y. In set X, we can see we have Ghana, Nigeria, USA, and Togo. Let's look at the elements in set Y each country corresponds to. If you take Ghana, you see that it corresponds to what? CD. Nigeria is what? Naira. USA is what? Dollar. And Togo is what? CFA. Good. Now, if you see all these things here in the Y, what comes in mind? You realize that all these are examples of what? Currencies. And all these are examples of what? Countries. So if that is the case, one would say that this is what? The currency of. So the relation here is what? The currency. The currency, or the rule is what? The currency. The currency of. So the currency of what? Countries. Have you gotten that? Good. So the relation we are talking about, how do they what? Relate? How do they connect? Okay. Yes. Great. Now let's look at the examples. Example 3 and 4. If you come to set X, you realize that we have 1, 2, 3, and 4. And each of the element there corresponds to elements in Y, which are 2, 4, 6, and 8. So, based on the first two examples, we are able to identify the rule or the relation between them. Let's look at the relation between example 3, X and Y. All right, good. So you see that we have one maps onto, or one corresponds, or one matches to 2, and we have 2 also matches to 4, 3 matches to 6, 4 matches to 8. What comes in mind? What specific rule can you assign here? You realize that anytime we have 1, we will also have 2 in Y. So it means that something has happened to what? 1. And what happened? What happened is that I think if I should multiply 1 by 2, I'll get 2. Now we have 2 here. It corresponds to what? 4. If I multiply 2 by 2, I will get 4. Let's move on to 3. 3 also matches to what? 6. If I multiply 2 by 3, I will get 6. If I multiply 2 by 4, I will get what? 8. So they suggest that each of the elements in X is twice of, or it multiplies what? 2. Okay, so in this case, you can see the relation in example 3 is what? Twice of, or multiplied by 2. That is the relation, or the rule. So if I ask you to state the rule of this relation here, you can say this is what? Twice of, or multiplied by 2. Twice of what? Twice of the element of X gives us element of Y. So you realize that almost all the values in the Y are always what? Depending on whatever values in the X. Alright, good. If that is the case, then we can say that these values in the Y are what? Dependent. They are dependent variable. We can call them what? Dependent variable. Now, in our definition, we made mention that elements in what? One set called domain, an element in another set called what? Codomain. Now, which of the sets can we say that these are the domains and these are the codomain? All right. So always the first set, which are the X values. Okay, the first set, they are referred to as what? The domain. they are referred to as the domain. So looking at the X, the set of X, you see we have Volta, Eastern, Ashanti, Greater Accra. All these are what? The domain, all right? And those values or those elements of Y are also referred to as what? The codomain. And since they are always also dependent on the element of X or the domain, we can also call them what? The dependent variables. So when we ask you to tell us what are the dependent variables of this relation, we are referring to the elements in the codomain. We can also call the elements in the codomain what? Images. They are also what? Images in the sense that you see that they relate to element in the domain. Okay, we can also call the same values in the codomain as what? Range. We can also call them range. So here I'm giving you different kinds of names that we can call the codomain. One is what we can call them dependent variable. We can also call them images. We can also call them what? Range. Okay, but now next lesson we shall look at what the range, the images, the dependent variables are. All right, great. If that is the case, then let's go back to the examples, the diagrams I've drawn. Let's look at the fourth one. So look at the fourth one. I know you'll be able to tell me the rule or the relation here. You see that we have X values which are 0, 2, 4, and 6, and we also have values for Y which are what? 2, 4, 6. What rule do you think, or what relation is between set X and set Y? So you realize that if I have 0 here, it corresponds to what? 2. If I have 2 here, it corresponds to what? 4. If I have 4 here, then it corresponds to what? 6, and the 6 here corresponds to 8. So here we can give the rule as, okay, let's try this. Let's say if I should multiply 0 by 2, will I get to know? When you multiply any number by 0, you are still getting 0. But looking at the first one, you realize that when you multiply 2 by 0, you didn't get 0, instead we got what? 2. So how then did we get the 2? It means that I've added 2 to 0 to get 2. Okay, when I add 2 to 0, I'll get 2. Then let's move on to the next one. If I do the same, I will get an answer. So if I add 2 to 2, I will get 4. So this one also works. If I add 2 to 4, I will get 6. It also works. And the last part, if I add 2 to 6, I'm going to get what? 8. Great. So this means that the rule can be what? It can be what? 2 more than, meaning if I add 2 to what? X values, I will get what? Y values. So the rule can be what? 2 more than. Yes, that is the rule. 2 more than what? 2 more than the X values. Okay, the X values. So let's say if I represent the X values as X, then it means to get the Y, I will just add 2 to it. So it will be 2 more than the X values, which will give me what? The Y values. Now I'm representing this X with the domain, and then Y with what? Codomain. Okay, so it means that the Y will depend on the X, okay, to get its value. You get it? Good. So this becomes the relation. So we want to know how do those sets relate to each other. All right, so how do they relate? So this is all about relations. We know that there are a lot of what? Relations in our families, our community, our various denominations and all that. Okay, in our life we relate to one another. Okay, great. So we shall end here and continue next time. Now in our next lesson, we are going to look at the various types of relations. All right, great. So I'm your facilitator, Evans Okay, a mathematics teacher. This channel is Mazuris TV. Don't forget to like the videos, subscribe and share. I'll see you next time. Thank you.